everyone. Thank you for joining. I know it's been a long morning already, so we'll try to keep it a little bit more interactive so that it's not boring and not just set of slides to talk through. So what I'm going to talk about right now and go through as part of the little bit of workshop kind of setup is how do we enhance security in delivering application in cloud native environments, and we'll talk about some of the trends in the industry, like how our companies and enterprises are doing it. We'll interact about it, talk about it with you, how you are doing in your company right now, and we'll go through that and see how it goes. You don't necessarily need to have a laptop to do any of this, but if you have a phone, I think we can make it a bit more interactive. So quickly touching about the agenda, we'll talk about innovation and why everybody knows why innovation is important, but innovating securely has become more important from tech perspective, and how do we help innovation of the business by enabling innovating securely on the tech side. We'll talk a little bit about supply chain vulnerabilities and how that comes into play in the security aspect. We'll touch a little bit upon shifting security left and building secure supply chains. It's not necessarily a secure supply chain workshop discussion, but you'll see throughout the discussion, security will come into the play in each aspect of application delivery in a cloud native environment. I wanted to take a moment and kind of use this as an interactive. I don't know if this shows up in my display or not. Does it go here? Let's try. And I can send it to, yeah, go ahead. I'm trying to see if I can send my browser to the display. There you go. It's mirroring. Oh, let's do this. Maybe this is better. Yeah, I think this will work out better. So just to make it interactive, you can, with your phone, scan this code and it will just pop up this question, and you can add your answer to it. It just gives a good idea for like what kind of audience we have. Like, are you developer, are you DevOps, are you InfraOps, are you SRE? What role are you playing? Are you in the product side? I'm missing quite a few, which are in others. Anybody from others want to share? What is your role? Cool. So we have a pretty decent mix of developers, DevOps, infra engineers, platform engineers. So like pretty much entire life cycle of an application. And I see 2 product managers as well. That's great. So we have the product side, we have the engineering side, we have the development side. Let's go back to the slides. So why essentially developer velocity, and setting the context, like why for innovating securely and innovation, developer velocity is important. And this is one of the McKinsey report from 2022, and there have been more updates to it as well. But I think at this point, everybody agrees in the industry that developer velocity and having higher developer velocity gives the organization an innovative edge. And companies overall who have higher developer velocity are performing better from the business perspective. And like one of the other indexes which they published is higher developer velocity index brings the companies into the top quartile, and top quartile companies are almost 5 times more revenue generating and has 5 times more business impact if the developer velocity is in the top quartile. So I think at this point it's pretty given that how do we help developers to go faster and build business features for the business. And I think this goes back to the goal of application development and goal of technology team is to how do we innovate and build more features for our customers and our users, and how do we get them in the hands of the users. And so setting that from the context perspective, I wanted to kind of bring this up and understand, does your, as a developer, as we saw, we have many roles. As a developer, what rollbacks do you have? As DevOps engineer, what do you see is slowing down your development team? Or as an infra and platform engineer, from your perspective, what is slowing down your development team in releasing your application and application features faster? So I wanted to kind of also use this as another and go back here. And if you can scan this again and just add top 3 pain points which you can think of from your perspective or your developer counterpart perspective, what are the 3 top pain points slowing down the velocity? And it could be very well that you are pretty high in developer velocity and you're not slowing down. That's fair too. Hope it shows up. Fair. QA process management kind of gets into the process part of it. Testing, code quality. Bad or missing unit test. That is infra fragility, broken pipelines, security, too many tools, silos. I mean, these are very common problems. I think if you look at some of these problems, none of this is new. I mean, I think in the industry we've been having these problems for years, from the beginning of when we were just copying source code over to a server for it to run, to a point where we are trying to run everything automated. We're still facing some of these challenges. This is an interesting perspective to see that we still have issues around too many tools. We have issues around infrastructure, we have issues around code merge issues, lack of QA, lack of unit testing. going back here. So one of the things which I like to, where did my screen go? Here you go. Always bring up is one of the things which in the industry has become a pain point pretty hard is the complexity which we are seeing with so many tools across the board to so many different things in your life cycle. There are hundreds of tools to choose from. Platform team is figuring out which tools they want to use to automate what part of the platform. DevOps team is trying to figure out which tools they want to use right now. 6 months down the line, that project got bust. It's no longer being maintained properly. Now you switch to a different project and now figuring out like how do you automate with this one. So this complexity of too many tools is pretty common, and I've come across many teams who kind of are trying to address this challenge themselves. And then along with that, optimizing and maintaining the Kubernetes and cloud platform is also a complex overhead which everybody gets into. One of the things which I want to also call out from security perspective, as security was also there, security kind of acts as a gate in a lot of enterprises, and I think people who added security, I'm kind of guessing that the security is slowing you down because you have gates around security, which is stopping you to go to production faster. And this is just again one of the recent metrics from McKinsey report that the data breaches have been happening more and more. So security team is kind of under attack if you think of it all the time, and it's always on their head when something like this happens. Your data breach costs are really high. Some of these ransomware attacks actually start way error time. By the time it gets recognized, it's almost a year, sometimes 6 months before you even know that the bad actor is in the system and have been exploiting your data. So security team are, whether right or wrong, are right to push back on trying to address this issue because it's happening more and more these days. And if you really think of it, it gets down to a point where it's not that all teams or all application code has problem which needs to be addressed. Sometimes it's just like one weak link which causes a bad actor to get in, right? One database credential which was left as a default password and somebody got in through that. So in the whole security aspect, we are boiling the ocean. Our security team is boiling the ocean just to find that weak link, because that one weak link can lead to really big data breaches and cost a lot of money to the organization. So the goal is like, how do we help security team to ease on this, and how do we help as dev teams, platform engineers, and DevOps engineers to make it easier for our security team to not gate us and let us go all the way through faster, right? Innovate faster. One of the things which is prevalent now in industry is the supply chain, and how do you secure your supply chain, and how do you address the supply chain attack vector, and especially from the perspective of application developers, like how do you start addressing some of these things ahead of time? And if you look at from the application development perspective, and what application development teams can do is how do you address some of these vectors which can happen? Like how do you safeguard submitting a bad code to your repository? How do you safeguard from going from source code to a CI/CD pipeline and the code does not get modified? How do you make sure that your source has integrity? And then how do you make sure your build has integrity when you're going through from the DevOps team perspective, when you're building these applications, when you're packaging these applications, how do you prove that there has not been any tampering on the application which you're packaging and sending it across? So it could be the process of packaging your applications and sending it across. It could be the platform itself which you're using to build the CI/CD pipeline. And it could be the dependencies which you're pulling from, which could have vulnerability. So it kind of goes on both the sides. From the source and build integrity perspective, developers have to be more cognitive about how they avoid this, how do they detect this, how do they code for this, as well as DevOps teams, how would they make sure that in their life cycle of building the automation to get their application to production, how are they proving that nothing has been tampered with? One of the example which everybody might have heard of and kind of faced last year was the Log4j vulnerability in the issue. And if you think of it, a lot of teams in the large enterprise, what I've seen is, didn't even know how pervasive this vulnerability is for them. Yes, I mean, majority of Java applications were using Log4j, if not something else like SL4j. But was that affecting them? Was that vulnerability affecting them or not? And so because of the not having that understanding, the entire security team's stance was like, you got to go fix that. You have to patch your dependencies. We don't care whether it affects you or not, because you don't have a way to tell us that it affects your code or not. So let's go and patch it. And I was talking to last week to a team. They are still running in production with Log4j vulnerability, and they haven't been able to patch all their applications for Log4j. The ones which are in active development got done, but ones which have been running for like ages and nobody has changed any code because no feature announcements were required, there was no budget to change it, it's still running production code with Log4j. The team does not have an idea whether it is going to affect them or not, because whoever wrote the code is gone. In some cases, source code is not available. You just have the binaries running. So the understanding of whether you have vulnerable dependencies in your application source code is one thing, but also understanding is the context of that vulnerability and how it's going to affect you is also important. And it will help the developers to act faster on some of these things, and help security to know that, okay, do I need to gate this or not, and enable the process of going to production faster. So this was more of like dev focused and app dev dependency focused, kind of addressing on the developer side. Then you had the SolarWinds attack, which was more of the entire supply chain attack, which kind of gets into the umbrella and realm of platform team and infra team. That if you're using platform which has been compromised, how do you know it has been compromised? How do you make sure the provider which you're using, you're getting data and enough information from them to see whether the dependencies in the supply chain is getting compromised? In this case, the supply chain of SolarWinds got compromised, right? And through, I think it was Jenkins vulnerability, through which they got into their build system, injected vulnerable code into SolarWinds. That got deployed to all the customers of SolarWinds. Now, all of the customers of SolarWinds were vulnerable to this attack. So you see, if you think of it, there are two aspects of the attacks which you have to think about. Is one, when you're developing your application, how do you address the CVEs and dependencies in your dependencies, and how do you manage that? And then when you're running your application from the DevOps team and platform team perspective, the tool chain which you're using, is that secure? And how do you making sure that when your applications are using these tool chains, it's not getting tampered? So what industry has been pushing is, we need to shift security left to make it happen. We need to shift security left so that we can go faster and we do not have to face gates of security at the later stage of delivering your application to production. And it's fair as well, because the later you find security issues, the higher is the cost to get it to production. And even if it goes to production and then you find issues, it's even higher if you get the breaches. And if you shift security left and you do it earlier, you reduce the total cost of actually delivering this application securely. But I think one of the things which I have been developer all my life, most of my life. So the question which I always ask myself when I see this question is, what does it really mean for me as a developer to shift security left? And similarly, what would it mean for a DevOps engineer to shift security left? Or what would it mean to a platform engineering team to shift security left? That's it kind of leads into my next question. Let's see, where's my... And I've kind of added few options here. And if none of these kind of resonate from your perspective, then you can choose something else and we can talk a little bit about that. But what does it mean from your perspective, from as a developer or a DevOps engineer or a platform engineer? Thank you. So one of the interesting things which I'll point out is I think everybody agrees that secure coding practices is important. Making sure that using secure images and secure dependencies is important. Early CV scanning, dynamic testing. I see that the validating supply chain provenance is fifth, the last, and if you something else as well, we can talk a little bit about that. Anybody wanna add your thoughts on why do you think validating supply chain provenance is towards the end? Sure. Like, you want to take a stab at it? Like, why do you think, why in general the room feels that shifting security left will like definitely start with secure coding practices, and validating the secure supply chain provenance is towards the end? Sure. From the developer perspective, you're thinking from developer perspective, or you're thinking from like DevOps perspective? Sure.
So it kind of depends on the definition, but in terms of the full supply chain, some of that's outside of our hands, vendors, hands, for example. But what would kind of be your definition of this supply chain for software?
So what I would say from the perspective of both developers and DevOps engineers, whether you're using any other product or any other platforms, the visibility still should be there. As a dev team or a team who is pushing code to maybe even test at this point, I should have the visibility into that when I'm going from my dev to package to building my images and then deploying it somewhere, the path has not been compromised with and the path has not been tampered with. Whatever tools I used, whatever platforms I used. So that visibility should be there to me as dev team or DevOps team, that I can find that, I can gate that, and I can understand if there is any vulnerability. If the image which I built is the image which is getting deployed in the environment. The CI/CD tool which I use to build this image and deploy this image, that does not have any vulnerability and I have the provenance for that. That is not getting tampered with. So that also gives me information around possibility of tampering ahead of time before I get to a point where we are ready to release the code to production or release the code to user acceptance testing. And so I think from shifting left perspective, it would be good to see more and more of that validation happening ahead of time. That it's not just I'm finding CVEs in my application and my dependencies. I'm also finding whether the tools and chain which I'm using in my path to production is also valid and not being tampered with. And I can see it ahead of time. I don't have to wait until later in the game a security scan happens through security team, which tells me all the tools are working as expected. Now, agreed that dev team, a lot of times DevOps team might not even have any say and I wouldn't say, but would not have much purview of like what tools get used or not, or what platform gets used or not. I wouldn't say they won't have. I think platform teams would have. Platform teams will work with DevOps team to decide on some of the tools and chains to use. But having that visibility ahead earlier in your path to production will give you much more confidence on you going to production securely.
One thing which I have observed, right?
Yep.
Even the popular frameworks like React, Angular,
Mm-hmm.
downloading, when you install, it immediately shows that it has known vulnerabilities, right?
Yep.
So as a developer, I know it has a vulnerability, but I don't have anything avenues where I can go and fix it. Right?
Yep.
So what can I do? I mean,
So
I'm aware of it, but I cannot do much about it.
sure. So and that is where the context of the vulnerability is also very important. One, levels is sure. Like for example, if you have critical vulnerability, you should definitely look at how you can either look for the upgraded package, if not using the upgraded one. If there's none, if there's no fix available, then you'll have to look at what other ways you can solve from the source, from code perspective. Can you avoid using that package at this point of time and do it yourself in your code, right? That gets back to the secure coding practices aspect of it. Plus on top of that, it also, the context plays where is that vulnerability going to affect what you're trying to do in the code? And how do you understand that and gain that? For example, you're using a function within that, or you're using a view within that Node.js package, which does not have the vulnerability. It is somewhere else. And if you use it in a certain way, it might not affect you. Getting that context is hard. I think I haven't seen really good solution around that deeper contextual information about if I'm using this package and I'm using this way in my code, am I affected by the CVE or not? That is hard to get at this point. But I think one thing which we can get is if there is a critical vulnerability in the dependency package, can I avoid using it? Can I avoid either using that package, or can I go to a previous version which might not have it if it does not have a fix? And if it has a fix, can I go to the next version and use that package? And if none of these work, can I actually write that function myself? Most of the packages in, like whether it's Node, Java, or Go, are open source packages. You can actually go see what's happening in the code and resolve it yourself, build that function yourself and resolve it as of now. And maybe even in the process of that, contribute back to that package and say that this is a fix, go patch it. I know it's easier said than done.
Ideally, it is easy to say.
Yeah. Right. So, and that's where the context also comes to the play, and I'll show you one of the things around a lot of CVs which we also see in the dev, from the dev perspective as well as from security perspective. There's a lot of noise as well. We'll have a lot of CVs which are critical or high, which might not have any exploit probability. So there is, I'll bring that up, but possibly remember the organization which tracks the exploit probability of a vulnerability. So you could have NVD CVs reported in NVD database as critical or high, but this is another open source org which does the analysis on those CVs and tells you what is the probability in next 30 days this CVE can be exploited. That's first.org. Yeah, so that's another contextual information which could be helpful to developers and dev teams, even DevOps teams, that, okay, I might have a high vulnerability over here. There's no fixed packages for that, but is the exploitability probable? If it is low, then you can provide that information to the security team and say that, sure, we have this high vulnerability. We cannot fix it right now. The fix is not available, but the probability of this getting exploited is also very low. Versus if the exploit probability is high and the CV is also high, you should go back and try to see that how do we avoid this now completely, right? How do we write it ourselves? So all of those can together bring you a perspective of like, what should I do when I find a CVE when I'm developing? Should I go ahead if the exploit probability is low, very low probably? If there's a fix available, use that dependency, or even go to lower version if that lower version does not have a vulnerability. And if the exploit probability is high and you're using that package, then either try to avoid it or do it yourself. So like you can use those different tools to take a decision what you're going to do in the particular CV scenario. And it will be helpful if you can get those information easily, readily available to you when you're doing the development, right? Like in your development cycle, you can easily get your CV results plus the exploit probability, plus eventually if somebody can figure out how to give me context around, is this CV going to affect the way I'm using the package in my code, then I can make a better decision, right? Do I upgrade? Do I stop? Do I do it myself? Does that give you some context around that? If my laptop is slow, there you go. So some of the things which we just discussed, and we saw that in the poll as well. And this is from Microsoft blog on shifting security left. I should have added the citation as well. But there are different. You can say when you're shifting security left, you can start from development itself and go all the way to the operations. And in each step, can you do things ahead of time, right? In the plan and develop phase, you can do better secure coding, right? You can figure out like how can I use secure coding practices? How do we do peer reviews? Can we do maybe pair programming? How do we use some of the plugins with the IDE itself, which can give me more context and information? Then on the commit code side, you can run static code analysis. You can do security testing, functional testing in that in a loop of development itself. Then during the process of building and testing, dynamic security testing, how do you validate configuration? How do you do even testing like, do you have secrets exposed? And then when you're going to production, even if you go into production, you still have to continually make sure that your application is secure and working. For example, one of the common things is an app which went through the whole life cycle, which did not have any CVEs. 35 days later, a new CVE has been discovered for an app which is sitting in production. So, and the app team has gone to a different set of features and working on a separate set of features now. They need to bring it back to resolve that. It could be in the OS layer, it could be in the application framework layer, it could be in the application dependency and application layer. So teams have to react on that and fix those issues which are happening in production as well from security perspective. So in this world of supply chain, one of the things which, and I think there are a few other frameworks which industry has been tracking, but one of the ones which are pretty used in industry. I don't know if any of you are using any of the supply chain security frameworks or not, but Salsa is one of them. It was started by Google. Right now, I think a lot of large enterprises in the open source world are supporting Salsa framework. But essentially, it's a framework which defines kind of rules and methods which you can use to detect security issues, whether it's in your build, during your build process, while you're doing your development, or or during your whole development process. And on the delivery side, once you build that application and build your images, how do you kind of secure your supply chain in that? The aspects which kind of goes after is the source, security of the source, the security and provenance or security of the build, the provenance of the supply chain and source code and the tools which you're using, and some of the common aspects which gets into like access to the environments, access to the source code, and things like that. But essentially, this framework builds upon the idea, like when you're going from pod to prod, what are the controls you can use from source perspective? What are the controls which you can use for detecting and preventing from build perspective? What are the controls you can use for proving your provenance? And then some of the common security controls. Is anyone of you using any security framework for your pod to production? So check this out. It's spelled as SLSA, and it kind of walks through the framework as well. And then one other thing which in supply chain security comes into play is software composition analysis and provenance. It is more of like having the information than in the case of like how do you what do you do when you find something, and also proving it, like when you are building an image to deploy, and you have an application, you build an image to deploy, and then when you're deploying it in production, how do you make sure that the application which you built is the one which is getting deployed? And that's where the software composition analysis and provenance comes into the play, that the packages which you have built and the bill of material of that package aligns with the application which you're deploying in production, as well as its bill of materials and who created it, and is it a valid package to deploy. So all of this along your life cycle comes into the play from the perspective of secure coding practices, securing your supply chain, and improving when you're deploying things that it is the application which you built is getting deployed. Kind of getting into a little bit of I don't know if it's too small, but an example path to production, right? Like when you are, and this could vary for different teams and different for different enterprises, but in general, you have the aspect of developers are building an application and in a loop, building and developing their applications in their either local sandbox or in your local environments. Then you get ready to push your application to your next environment and enterprise. Whether this part is already there or you have to build it, you have several aspects of the environment to build out from the infra team perspective. And once that is there, from platform team perspective, you're building out different, either whether you're using Kubernetes and containers for deploying your applications, or you're using cloud platform and cloud to deploy your applications. You are, as a platform team, you're building that out. And if you think of it, each of these steps are not just done once and done, and you don't have to do anything about it after that. It is a cycle which repeats itself. It goes from day 0 to day 2 and beyond, because platform team has to continually update the platform they are presenting to the developers. Infra team has to continuously update the infra side and upgrade the infra side. And then your application teams and DevOps teams, CI/CD comes into the play. How do you get that application to production? And then for DevOps team, you have that loop as well, where DevOps team have to continuously make sure that the pipeline is updated if it needs to be. And then you have the app running in the environment. The reason I wanted to show this example part of production is to kind of highlight some of the practices which are there in the space, and what are some of the hinders on those examples, right? We are using Terraform and Helm charts for managing environments and managing applications on clusters. From developers' point of view, it's a lot of context switching. From probably DevOps point of view and InfraOps point of view, it is not. But for developers to do this and maybe deploy their applications through Helm chart is lots of context switching. For app teams to adapt a good starting point, adapt templates to use, adopt pipeline templates to use, also kind of hinders if they don't have a good central DevOps team or central team which is driving that aspect of templating and providing good starting points. Upgraded patches, if it's kind of driven towards individual teams, that also becomes higher risk instead of driving, especially when you are also sending it to the individual application development teams that you have to manage your entire layer of application chain, right? Whether it's the OS layer, whether it's the application framework layer and the application layer. If the individual development teams have to manage that and drive that, like what goes in my Docker file, it brings up the higher risk of vulnerabilities. Per team package management gets into increased cost to coordinate. Per team pipelines also makes it harder to kind of manage that estate across multiple development teams. And then the compliance and security guardrails, which we have talked some of those about, if we address that in a reactive way, then the compliance gets lapsed and you have delays in go live. So to address some of these, some of the aspects which I've seen a lot of enterprises are taking is driving kind of your developer experience with the concept of golden path to production. And kind of came with this golden path to production idea was kind of brought up by, I think it was started by Spotify and some other companies back in the day, but it has become more of a prevalent thing with the platform teams, that how do you build secure path to production? I think a little darker to see, but how do you build secure path to production so that your developer teams across multiple groups are using one or few of those secure path to production which you've been able to automate? And then how do you build runtime as a platform team for your developers, which can work across multiple clouds, but it does not change your golden path to production to work on those multiple cloud environments. I think Kubernetes also plays containers primarily plays a big role in that aspect of building that multi-cloud app runtime. So kind of addresses those, right? It reduces the toil on developer experience. You have standardized golden path to production, and majority of teams are using that path to production. And then you can enforce policies, you can enforce governance and pipelines. So essentially it's going back to the whole concept of platform engineering and why platform team are building platform for developers so that we can improve on the DevX side of things. So I know this was quite a bit of slides, so I wanted to quickly see if we can do some hands-on, right? So I just took an example of that, of taking an application to production, and some of the So once you have the source code, consider that you are doing secure coding practices. What would it could take to deploy your application to production securely and have a bit of those guardrails and provenance in your supply chain. So, for example, you start with some sort of a GitOps option. You can use FluxCD for that. Some CI tool, Tecton or Argo CD. Scan source using Gripe. You have Trivi. There are other tools out there which you can do for scanning your source code and getting your CVE information. You can build image through Dockerfile, or you can use BuildPack, which kind of builds your image from source code. You can generate your software composition analysis in SBOM using SIFT. And all of these are open source projects out there, which you can try to use. You might be using some of these already. You can sign an image with cosign so that you can use that for provenance. And then you have tools like Customize when you are deploying to Kubernetes. There are other, like you can use Helm charts or you can use Customize. But essentially the idea is that when you're building this path to production for your app teams, you build that golden path out, automate all of that. And for developers, they should just push their code to the repository, and everything else should be taken care of by the automation. But anybody wants to try doing this right now? And we'll just have to download 1, 2, 3, 4, 5, 6, 7, 8, or 9 tools to make it happen. And you can download it from landscape.cncf.io. But what I also wanted to kind of take an opportunity to show is you can try this out I think I apologize, I forgot to introduce myself. And I can go quickly over there. So, and me and Paras, we are co-founders of Initialize.ai. And what we are doing is we've built a DevSecOps platform, a unified DevSecOps platform to build this golden path to prod. And you can use the platform to try it out and go from source code to all these things happening in your path to prod automatically without doing any configuration. And then you can build your platform and then build your customization on top of that. So if you want to give it a try, you can scan this and register and give it a try. I mean, it should be pretty simple to get started. But Paz, do you want to quickly show an example of it? Yeah. And you can come over here and I think it should show up. Yeah, screen mirroring. Did I pull it? Yeah, here you go.
Let me know when you guys register so I can do it along with it.
If you want to try out, you can register and try. Yeah.
Registered.
Let me bring the QR code quickly. If you want to try.
Good. So like
once you register, you'll come back to the same screen to do a login with your email, the one which you have used for the registration. And once you log in, you'll see the screen which will come in front of you.
Let me see if I can make it bigger.
Yeah. So what we have to do, we have to go to the create app. This is where when we want to create the app, we can come here and do a app name, for example, workshop. I can go and connect to my Git where I have my source code, which I have to just bring and run the stuff I have already there. I can use like any of the repo which I want to build and deploy. Go and choose the branch which we want to use for this. Click next. Since this is Spring Boot, I'm going to do it on the 8080. If you're using a different stuff, we just need to use for our own port where we want to do it, the path. Next.
I just want to add, anyways, so you saw that there was an option for environment variables. You can inject environment variables in that screen as well.
So it start from there. It will start cloning the code from the Git repo, which we have connected, and it will start packaging it from there. And you have all the logs and everything coming in front of you with all the details. You will have the URL. Meanwhile, you get the key also into your email, the one which we have been connected. So it's kind of a secured, and you will have the key. It goes from the clone to the packaging. You can see here all it's preparing it, creating and creating the Docker image for you. It's a signed Docker image.
Plus, while it's doing it, you can probably go back to the application which you already have. And show the.
Yeah. So you can see in the package, you'll see the app, the image with the signed URL. We can see it's prepared, create, and then we have the results with the signed URL. Then it goes to a SCA, where you can see the complete SBOM detail of the application or the code what we have, and it can be export from here. So we have all the information, complete software bill of material with like all the packages, versioning, and everything from the infrastructure to the application on top of that. It goes to the scan, which it brings the whole CV results based on like what kind of a severities we have, and if we do have any fixed versions for those severities, and if we want to tackle it there. If it's like critical or something, it will just, based on the policy, it will stop. The pipeline will not go to the next unless we bypass that, or we give the policy some leniency, and then it will just allow. After the scan, it comes into the deploy test, and it creates an environment there for you, and we get the URL for that environment, and it deploys, and then we have an application running on the cloud with the, like, if we see it's HTTPS URL, which we get here. And once we have it in the test environment, if we do the testing, or if we approve, do whatever, it goes, and then create a stage environment for you and deploy, and you get the same secured URL for the stage, and the same it goes for the production.
Probably you can walk through the security screen to.
So now we have a stage URL. We can see into the security also for the application which I have used. It's based on the workspace, so it will give you the consolidated view, and we can go there and look for that particular app also, like how many apps are running in my workspace, and out of that how many are compliant, how many are not compliant, and what my policy compliance percentage, and all the CVs which I have currently in there. I can go and choose based on my workspace, or can do all the workspaces. In down, we can see my apps running and what are their status, when was the last the scanning was done. I can download my SBOM and CV details also from here. I can go and look more in detail to see in that particular app, and then look the kind of a trend, all the CVs which are there. If I need even more detail, I can go to those CVs, and this is, I think we were talking about exploit probability. If any high severity CVs are there, and if there are any probability available for that, you will see the score and the probability for that CV.
If it's pick that one, we'll
Like this, so it tells there is a negligible probability that the CV will be exposed in next 30 days, and this gets updated on a daily basis. It may be not possible in the probable today, but it may be after 15 days or 20 days. So it will give you the idea when to take action on that and reduce the unnecessary noise.
How you are deciding?
So this is an algorithm. It's an open source project which has been sponsored by all the bigger security companies. They are running, and they have built the whole AI algorithm on top of that. So based on that CV, they go and scan and look comparable all the CVs of the same nature, and then they see what kind of a trend is happening, and then they came up, and then we are bringing the score from there and adding with the your priority based on the high, low, medium, and then we are bringing this score and giving the EPSS score. It's an industry term used for that, and then we are giving the probability. What are the probability are there for the next 30 days?
We are also working on, so right now this is at the individual CVE level. We're trying to build the data model around it so we can show you at the application level that, okay, you can go to individual CV and find out how probable that exploitation is. But can I give you information at the app level? Is your app exploitable at this point or not? So we'll be releasing that update as well. And hopefully we'll also try to contribute it back to the first.org, which is doing the CVE level exploitability score.
So this is the one which I have used for this workshop, and we see that the app is there and already deployed, and it's running like workshop.test.initialize.run, and the same way it goes for the stage, and then for the prod, and then from the domain we can always map it.
So I can configure my own load up on this.
Yeah, so this one right now is completely SaaS-based. It's managed on our environment. Essentially, we're running everything on Civo right now. So we're using Civo Kubernetes. But we are going to add the first ability which you're going to add is to bring your own cluster where you will run the application. So the control plane will still run on our SaaS, and your cluster is where your applications would run. And you can configure the domain to go to that cluster. And then our plan is for enterprise deployment to give the self-hosted option that you can run both the control and your application run clusters in your own cloud, on your account, or in your own on-premise. But the first one would be that control plane is running on our side, the applications are running on your cluster. And the access to that is, the only access we would need is the ability to create a namespace and manage the objects in that namespace of that cluster. So, so as part of that, we'll also provide that the either IAM policy or the RBAC, Kubernetes RBAC you would need to provide to us so that we can deploy applications in your cluster. Did it work for you?
I got to the test approval stage, and then when I approve it, it says some error occurred.
Okay.
And it's a Dockerized Express.js project, but no biggie. It looks like a very cool tool, so it's really cool. Actually, it published a live test URL.
Yeah. Yeah, and the main goal which we have with is to bring that information up front to give you the ability to iterate faster and give you information around what's happening with your CVEs, what's happening with your SCI. One of the things which we are trying to bring is, this is like when you have your source code done and you want to push it. We're trying to also bring it to the IDE plugin level, like whether you're using VS Code or using Eclipse or JetBrains, you can actually get some of that CV and SBOM information ahead of time and exploit probability information ahead of time in your IDE itself. So that as a developer, when you're doing that, you would get to know before you push your code to Git repository and merge your pull request.
Do you know if any like SSH key is required in this process?
So when you authorize the Git repository, we generate a deploy key for that particular repository, and we use that SSH key.
So it generates its own SSH key.
Yeah, yeah, and it is per repository based, so you don't have to give like the World Wide Web permission, right? Like you provide permission specific to that repository, and creates a key just for that repository. So you can choose and remove from that particular repository.
Yeah, it's very cool to automate this for setting up its test stage.
Yeah.
And prod. That's great.
Yeah, and this is like the out of the box, you can say supply chain template, which we are using. We are working on providing the option to choose multiple different types of templates and add some of the steps which you would want as per your custom need, right?
And I really appreciate the aspect of the CVEs. You know, often it's kind of like a false positive of some.
Yeah.
You'll see, oh, there's some problem, but really it's a very small chance.
Yeah.
The CVE is not been relevant to your project. So the probabilities aspect is very cool.
Yeah, and the other thing which we're doing is when we run things in production, once it goes to production, we're running a daily scan on, and in fact, we're not actually scanning the application itself, we're scanning the SBOM of it. So it's much more faster. And then if there is a vulnerability, and if it is in the layer which is beyond whether it's in the application framework or OS layer, then the build pack process which you saw, that patches, if we have a patch available, we'll push a patch, we'll patch and create the image again, and give you an option to either auto push it across to your test environment, or it'll patch it and will make the image available so that you can choose to whether you want to go to the next environment and test it out. And on the dev side, I'm sure a lot of you might have been using Dependabot, especially for open source projects. You might be using Dependabot. We're bringing that construct within the application development loop, that before you even push your source code to essentially across the pipeline, can you start upgrading your application automatically like Dependabot does. So if you're not using open source GitHub, or you're not using GitHub's advanced security, you can use this Dependabot-like construct of ability to update your dependencies if there is a patch available.
Yeah, I think this is a really great tool. It's necessary. It's like taking Dependabot to the next level
Yeah,
throughout the whole supply chain.
yeah,
And I see it's the pricing. It has a free tier, which is really nice.
yeah.
Who are some of y'all's customers currently?
So right now, most of our customers are SMBs and startups. So most of the most number of applications which we are running at this point are around 8 applications for an organization. So we are the smaller application or smaller business stage at this point. So we have a health tech company called SanData. It's based out of Tennessee. And we are also working with few of the larger enterprise and having conversation with them. And the most asked for those enterprises are, can I self-host it? So that's our next direction. Like, how do we make it available so that you can host it in your cloud environment? But yeah, what we've seen is for startups and SMBs especially, and one of the reasons we also work very closely with Civo is startups and SMBs who want to go fast are much more open to using complete SaaS-based environment. And that's where we are seeing much more traction from our perspective at this point. And what we've seen is startups also have the problem of like they do not have large teams to make this happen from DevOps and platform engineering perspective. So they're looking for help in terms of how do I get something pre-baked and pre-automated so that I can focus on building capabilities which I'm building as part of my startup for my users.
It's really cool. It reminds me of Vercel, for example.
Yep.
This is kind of like the Kubernetes analogy to Vercel.
Yeah.
Very cool. And I don't want me to like dominate the conversation. Unless anybody else has any questions, I was wondering like, what are y'all's backgrounds, or like, how did y'all begin developing this product?
Sure. I know we're almost out of time, but I'll take a quick minute to do this, answer this. So both of us, we started off as developers back in the day. Paras can tell a little bit about his, but he worked at Amdocs and worked on the product engineering side. I started off in the consulting side, then got into enterprise, spent a lot of years in the enterprise trying to go through the processes to get something done. I got into cloud and Kubernetes around 2014 timeframe. In fact, 2015 is when I met Kelsey Howard. Actually came to the company which I was working at. He did a workshop over there for Kubernetes, and that's how I got into Kubernetes and cloud era. We've primarily have deep background on application development and cloud engineering. Cool, I think we are up on time. I hope this was helpful and informative and you got some good tidbits out of it.